as we begin to discuss our operations with polynomials, it's going to be essential for us to get used to what it means to be a like term and how to combine like terms. Now, here's a list of terms. This is not a polynomial. I just kind of listed out just a set of some terms here. You can see that each one has their coefficient, their exponent, and we can look at ones and whatever's been anything else. But to be a like term, when we look at this list of terms, like terms are a 3x to the fifth and a 2x to the fifth. Non-like terms, even though those are both x's, because one's to the fourth power, one's to the fifth, not like terms. Even though when I see things like the same coefficient, even if that had the same coefficient, that would not have mattered. Even though those are both 2, the fact that those are different exponents, they are not like terms. It needs to be the same exponent, as well as over here where we have a 5x to the fifth, because that's a 5y to the fifth, because that's a y and that's an x, we need to have the same variable, or the same base, whatever you want to call it. But in general, you need the same exponent, and you need the same variable. And we will see those later where we have the different variables, but that's how we're able to identify. Now, we can also say 5 and negative 8, which if you remember from before, those are both your constants. Of course, your constants would be like terms. You don't have a variable, and you kind of have the x to the 0, whatever you want to call it, but constants will always be like terms. In fact, those are just 2 integers. Where we're going to see this coming up in our next few sets of problems are when we have to combine like terms. When we have that 3x to the fifth and that 2x to the fifth, when we combine those, where this is going to look slightly different, is our variable and our exponent stay the same. Where before we'd be adding exponents or something like that, that's if we were trying to multiply. If I had 3x to the fifth times 2x to the fifth, that's when I would multiply my coefficients and add my exponents, but that's not what I'm doing. When I'm talking about combining, when I'm talking about adding these, all I'm going to do is add the coefficient. Think of this as x to the fifth. Remember, the b to the fifth power means x times x times x times x times x. The base times itself 5 times. 3 times that means I have 3 of those. Over here, 2x to the fifth, what makes it a like term is that it's a product of those same 5 bases, which then kind of goes into why we need the same exponent and why we need the same variable, because it needs to be the same product of the same base. But notice the reason I just had the coefficient, if I have 3 of them and I have 2 more of them, I have 5 total x to the fifth. And that's also why we do not multiply or add the exponents or anything crazy like that. And I know it seems different, but again, that was when we had the power of a power, power of a product, all of those type of examples. When I'm trying to combine like terms, I recognize same variable, same exponent, add the coefficient, the variable and the exponent need to stay the same. I'll often then follow up with students, what if I had the 3x to the fourth plus 3x to the fifth plus 2x to the fourth? Would I now add the exponents? Is this going to be my 5x to the ninth? But what we would say is, again, because they are not like terms, I cannot add these. And in fact, my answer would be what I started with. What I would say is I just can't combine them. So that binomial, 2 terms, is my answer to this problem. So just kind of recognize when I can combine, and when you do, all you do is add the exponent, variable in your exponent, stay the same.